So kenalkan diri dulu.
The police weather condition on the surrounding and solar irradiance location along with load consumption. And the last one is confirming the applicability and advantages of solar technology. Okay, next.
For the next part is introduction. I will be presenting this slide. What is solar energy? Solar power is energy from sun that converted into thermal or electrical energy. Solar power is conversion of energy from sunlight into electricity, either directly using photovoltaic or indirectly using concentrated solar power. It is the cleanest and most abundant renewable energy sources available. Solar technology can harness this energy for a variety of uses, including generating electricity, providing light or comfortable interior environment, and heating water for domestic, commercial, or industrial use. Solar energy in agriculture. The form of energy can be used for solar irrigation. It can likewise be used to pump water for livestock and crops. Solar heat collectors can be used to dry crops and warm homes, livestock building, and greenhouses. Solar water heater can provide hot water for dairy operation, fan cleaning, and homes. Photovoltaic can power farm operation and remote water pump, light, and electric fences. Building and barns can be renovated to capture natural daylight instead of using electric light. This
Sorry,
form
Mai.
of energy.
Buka slide.
Huh?
Buka slide tu.
Buka slide.
Bagi slideshow. Nampak tu Datuk entire screen.
Dah buat dah.
Oh dah. Line number. Okay. Sorry.
Okay. This form of energy can be used for solar irrigation. Sunlight emanating from the sun can be used to power home and agricultural houses with solar panel system. Internal reaction of solar energy. The radiant light and heat from sun is natural source of energy using a range of ever-changing and developing of technology such as solar thermal energy, solar architecture, solar heating, molten salt power plant, and artificial photosynthesis. The large magnitude of solar power available makes highly appealing source of electricity. 30% approximately solar radiation is back to space while the rest is absorbed by ocean, cloud, and land masses. The function of solar energy in drying up crops and grains. The agriculture produce can be dried faster than outside where they become prone to bird, insect, and worms. It can dry perishable goods without fear of getting damaged. This will reduce the number of damaged crops and would lead increased profit for farmers. How the solar energy work? PV cell convert sunlight into DC electricity. Charge controller work as control the power from solar panel which reverses back to solar panel get cause of panel damage. Battery system act as storage of electric power is used when sunlight not available, for example during night. From this system connected to inverter for convert DC into AC current AC. Benefits of solar energy: cheaper compared to fossil fuel and advanced approach, reduce pollution, global warming and dependence on imported fuel, and lastly reduce the number of damaged crop and would lead to a profit for farmers. Next is material and instrument. The first is solar cell, photovoltaic cell. The cell converted solar radiation directly into electricity. It consists various kinds of semiconductor materials. It has two types, which is positive charge and negative charge. It is used to design solar cells with low cost as well as high conversion efficiency. Next is photovoltaic module. It consists of solar cell circuit sealed in
Nanti
environmentally.
dulu.
Ya.
Boleh tak awak tukar slide ni? Saya nampak benda yang sama je ni. Dekat slide nombor 6 je
Itu.
dari tadi.
Buka slideshow, buka slideshow. Mana buka slideshow?
Dah, ada dah.
Ada. Buka slideshow dulu.
Tak payah buka slideshow, awak tunjuk je macam ni. Tunjuk. Tak payah buka slideshow. Kalau dah komputer awak tak boleh buka slideshow.
Sambung ke start dari slide 6? Okay, I will be continuing. Next material is photovoltaic module. It consists of solar cell circuit sealed in an environmentally protective laminate and are fundamental building block of PV system. Usually, a number of PV modules are arranged in series and parallel to meet energy requirement. Next is photovoltaic panel. It includes one or more PV modules assembled as a pre-wind sealed in stable unit. This panel PV cell is series connection. Solar panels are made up of individually PV cells connected together. Photovoltaic array. It is contained of several amount of PV cells in series and parallel connection. Series connection are responsible increasing voltage of module, where parallel connection responsible increasing current in array. Large the total surface area of array. The larger the total surface area of the array, more solar electricity will be produced. Next part is calculation and result. I will be passing this part to my groupmate.
Okay, the calculation that we get in the solar radiation in police is the daily average of solar radiation throughout the year of 2006. We get this information in 2006 only.
Siapa yang cakap?
And we Izham.
Isham, terang jelaskan siapa cakap. Okey. Kan awak ada permulaan. Okey, my name is, terus mulakan. Sebab saya tak nampak siapa yang bercakap ni. Okey.
Alright. My name is Muhammad Izham. Will be explain how the calculation works. As we look at the graph in the daily of the year in solar radiation, the highest total daily average solar radiation is 7,238.89 watt per hour millisquare and was recorded on 7th of March. And the lowest is recorded in 20 March, 1,130.56 watt per hour meter per square. Daily average solar radiation values were high during the period of January to April because of maybe the hot condition, musim panas, and the calculate all average daily solar radiation for the whole year was 5,031.45 watt per hour meter square per day, and the annual total solar radiation is released was 1,831.45 kilowatt per hour per year. Next. And this the graph of daily solar radiation in kilowatt per hour in average annual daily. The number of days is average annual daily solar radiation greater than 3 kilowatt per hour was 336 days, which indicates that the sky in Perlis was clear for 92.1% of the days in a year, and the solar radiation intensity was very high for these days. Solar radiation between 1 to 3 kilowatt per hour per meter square was 29 days, or 7.9% of the days in the year, still suitable for photovoltaic application. And there's no solar radiation lower than 1 kilowatt per hour meter square, which indicates that no days in the year were absolutely cloudy days which were not good for photovoltaic application. Okay, next. Next. Next.
Dah next dah.
Nanti
Peak sun. The peak sun in Perlis for the year of 2006. There's a peak sun in January to December. It had the lowest peak of sun of 4.37 hours, and the highest is 5.93 hours is in March. The average is 5.03, and it was greater than 3 hours, which indicates that peak sun hours in Perlis gives potential for photovoltaic power generation. Okay, I will give to Akil this slide.
okay, Assalamualaikum. My name is Muhammad Akil Iqbal. I will talk about the formula used in the calculation. Okay, based on the genre that we have been using, this is the only one of the equation that have been discovered. Okay, E equal to the electrical energy that we produce equal to A, the total area of the panel, divide times R, the yield or the efficiency Okay, H is the annual solar radiation and divided by PR, the performance ratio. Okay, from the journal that we get the total, the annual solar radiation is 1,831 and 45 kilowatt hour per meter square, like what Izam have said before. Okay, next. Okay. In order to find the energy, the electrical energy, based on our spec that have been using, like area we use our site is about 20 R. The R efficiency, the 13%, we get it from the journal. This is a minimum efficiency for solar panel. Okay, H is the annual radiation that we get from the journal that Idam has tell us about in the result. Okay, the energy produced from the specification that we get is 481.755 megawatt per hour per year, based on the solar radiation that we get from the journal. Okay, next. Okay, for the energy out, the available solar radiation is divided by area of original surface and the efficiency of the modulus, and lastly divided by times by the factor, utilization factor. Okay, based on the monthly solar radiation for the year of 2006, the annual solar radiation is 1,851.45 kilowatt hour per meter square. If the amount of solar radiation is converted to electricity by the photovoltaic technology, which its efficiency and utilization factor were 13 and 1 respectively, we will use the energy out formula that have been provided above. Okay, E out equal to 238.1 kilowatt per meter square. Okay, next. Next, I will talk about the discussion of the case study. Okay, based on what we have been researched, the parade has annual total solar radiation of 1,831.45 kilowatt per meter square for the year of 2006. Okay, it was it was higher than the usual annual solar radiation, which suggests the clear and very high solar radiation strength of sky in Perlis during the year. If the amount of solar radiation is converted by PV technology to electricity with its efficiency, it will produce a large amount of energy that have been stated before. Next. Okay, in order to predict the efficiency, it starts from 6% to 20%. Cited while looking to the solar panel. You have to be sure to compare solar panel efficiency rather than the solar cell efficiency rate, as we described in another solar bulletin. You may want to inquire about loss of productivity from the initial break in the way. High quality panel will retain the rated performance, but solar panel of lower quality will lose up to 33% productivity during the initial sunlight exposure. But this loss is probably avoidable. In Perlis, there are 3 essential factors that must be taken seriously to improve the efficiency, which is temperature, shading, and soil. I've been go through it at the discussion about it. Okay, that's all from me.
The conclusion. In this case study, based on solar radiation data for the year 2006, the average in total of solar radiation was 5036.252 watt per hour meter square. It was greater than normal solar radiation in its 3 kilowatt per hour, which indicates that the sky in Perlis was clear and very high solar radiation intensity for the months in the year. The annual total solar radiation in Perlis is 1831.45 kilowatt per hour, which will generate a total electric energy of 237.7 kilowatt per hour per year of the photovoltaic module. And of all land, the police were filled with horizontal PV panels. Nearly 189.29 gigawatt per hour of electricity could be produced per year. And this shown the big potential of solar radiation for power generation in police. I think that's all for today. Thank you.
Very good presentation. I think it's not that good lah, but it's good at time. However, because you are the first presenter, group presenter, there's a lot of unknowns you need to do at first. But I think you should know that before you start present. Introduce yourself, and when you try to pass to your group member, and good passing words, you should elaborate. And once your group member start to presenting, and introduce again your name and everything, and start. Okay, that's the way how you present in the group. By the way, by looking at your report, I received your report from the Google Classroom. You have how many you have? You have around berapa ni? 7 objective. You have 7 objective. Why you have a lot of objective? Boleh jawab dekat saya, Akil. Can you answer me?
We got a lot of objectives because we aim for do it the case study like a reality one.
Like the reality one.
Yeah. Like we want to achieve the case study that like it was our own farm.
Okay.
Solar farm.
Okay. That's good. That's good attempt. However, all the objective you need to achieve, right?
Mm-hmm.
And you have a properly methodology for all that objective. For example, number 1, to promote ecological sustainable growth while addressing Perlis energy security challenge. You need methodology, and after that you need result in discussion for that methodology. Okay. Also, in the conclusion, if you have a 7 objective like this, you need 7 methodology, and you need 7 all of those results. Okay, and you need to conclude them. Okay, that's good. Akil, now Izham.
Yes, sir.
Izham, can you explain to me the formula that given, that explained by Akil just now?
Okay. Discussion.
No, explain to me on the formula that explained by Akil just now.
The
formula.
The formula that Akil give is the.
Explain to me. What is the formula? Show me the presentation slide and explain to me.
this formula is calculate the energy. We make sure the total solar panel area in the location block, and we calculate the solar panel yield or efficiency in the total area, and we
Okay.
Absolutely.
Simple question. For the A, total solar panel area. That's area of what?
area of the solar panel in the whole solar panel.
The whole solar panel.
Yes.
Okay. How about the R?
The R is efficiency
Efficiency of what?
of the modulus in the solar panel.
Sorry?
The modulus in the
The modulus of solar panel. Okay.
solar panel.
What the efficiency tell you about?
The power of the solar panel in the by using and get the kilowatt per
Can
hour.
you explain? Can you give me example of efficiency for solar panel
Efficiency.
so that I can understand your understanding on efficiency?
Can I help?
Cannot.
Oh, cannot.
Akil dah jawab. Markah dah ada. Izham. For example, Izham, you have solar radiation tu, you boleh ada 100 kilowatt, you boleh extract 100 kilowatt dari solar radiation awak. You ada satu solar panel, kemudian you letakkan kat panas, you dapat solar radiation tu. Solar radiation tu 100 kilowatt. Sekarang ni efisiensi solar panel awak cakap lebih kurang 50%. Okay, so berapa kilowatt yang tinggal?
Berapa kilowatt tinggal? Kilowatt dia
Contoh saya bagi contoh. Awak boleh bagi contoh awak. Contoh solar radiation yang boleh bagi ke awak pada satu-satu masa ialah 100 kilowatt. Kemudian you punya solar panel ada 50% efisiensi. So apa terjadi? Dekat you punya yang you dapat berapa watt power yang you dapat?
So kalau semua kita kira keperkesanannya dalam 50 kilowatt.
50 kilowatt lah kalau dia jadi 100 kilowatt. So
100 kilowatt.
okey. Kalau panas apa terjadi?
Kalau panas kilowatt tu akan naik dalam kilowatt.
Solar panel awak tu kalau dia panas apa terjadi?
Current efficiency akan naik.
Apa dia, sorry?
Efficiency dia punya keperkesanannya akan naik.
Contoh. Okey, kalau sejuk maksudnya dia optimum condition lah. Lebih kurang efisiensi dia lebih kurang 50%. Habis kalau tiba-tiba panas, solar panel awak panas, apa jadi?
Dia punya persen akan meningkat.
Efisiensi meningkat. Efisiensi dia bertingkat. Okey. Sepatutnya efisiensi dia menurun lah. Kalau dia 50%, efisiensi dia akan menurun jadi tinggal 30%. Kalau 100 kilowatt, dia boleh produce lebih kurang 30 kilowatt sajalah for one time. Okay? Thank you, Izham. Now, Mai pula. Mai, on the conclusion, Mai.
Ya.
Mai tak nampak ada 7 objektif tadi kan?
Nampak?
So, conclusion yang mana satu ni?
Ni calculation yang
Oh, kat sini ada 5. Dekat awak punya report ada 7. Okey, 5 lah, 5. Yang mana satu? Conclusion tu yang mana satu?
Sekejap, conclusion. Solar radiation.
Mai, jangan ambil masa lama sangat. Kita ada group 2.
Nombor 3.
Ha? To calculate the potential of solar photovoltaic power system in rural
Nombor
area.
2. Dengan nombor 2.
Nombor 2.
2 dan salah 3.
Apa?
2 dan 3. Hello?
2 dan 3 operating and maintaining photovoltaic. Kemudian 3 to calculate the potential of solar photovoltaic. Okey, jelaskan kat saya. Apa conclusion awak? Yang nombor 3 cukup lah. Nombor 2 objektif tu macam pelik lah saya tengok. Nombor 3. Jelaskan saya.
Potential solar energy solar
Jangan baca, bagilah saya faham. Saya boleh baca.
sekejap. Solar dekat area Perlis, the total solar tempat yang kita buat energy tu memuaskan. Perlis solar radiation of 1831.45 kilowatt power per meter cube untuk 2006.
Then
It has annual solar kat Perlis adalah tempat yang sesuai. So it has higher lah than usual solar radiation.
kat mana yang dia bagi tahu sesuai tu?
Kat Perlis.
Tak, dekat conclusion awak. Dekat conclusion awak. Mana yang bagi tahu sesuai?
Ikut ni discussion. Ada. Ada. Sikit bawah lagi 2.
Mai, saya tanya conclusion.
Solar radiation dekat Perlis. PV power generation Perlis.
Okay, so I can see lah. Your group ni ada dia tak sama-sama buat lah, senang cerita. You buat part you, you buat part you, you buat part you. So dia tak faham apa benda yang kawan-kawan dia buat. But by the way, that's good. You can improve later on. Terutamanya Mai ada ambil FYP kan Mai kan?
Ya.
Kan? Kalau ada ambil FYP sepatutnya dia basic format tu sama je macam FYP. Kalau ada objektif mesti ada metodologi, mesti ada discussion, mesti ada conclusion. Benda tu mesti selari. Tak boleh objektif 7, metodologi 2, conclusion 1. Tak. Kita kena selari benda tu semua. Okay? Thank you group nombor 1. Good job. Kita akan ada presentation for group number 2. Okay, thank you Mai and Izham and Akil.
Thank you, sir.
Okay.
Sir.
Ya.
Kalau saya pergi ke next class saya boleh? Saya tengah ada kelas.
Okay, no problem. Awak pergilah.
Okay.
Tak ada masalah pun.
Okay. Terima kasih.
Okay, sorry for the inconvenience, Doctor.
No problem. Next group, please. Please introduce yourself and you may start when you're ready.
Ada ke slide?
Yes, we can see it.
Okay. Assalamualaikum and a very good morning. Okay, my name is Assalamualaikum, very good morning to our lecturer, Dr. Zainal. Okay, today I will present about a case study of generated electricity from precipitation in Sandakan, Sabah. Okay, so this precipitation is basically a rain or snow that fall from any kind of weather condition. There's something falling from the sky. So basically the water that fall from the cloud towards the ground, into the sea or into the river. Okay, so we move to introduction. From this water, we think it's suitable for us to build the hydropower to generate the electricity. Okay, so what is hydropower? Hydropower is the electricity that comes from the force of flowing water, which is part of a continual natural cycle called the water cycle. Okay, this water cycle is start from the evaporation from energy from the sun that evaporates the water from the seas or the river, and then is drawn upward as a water vapor. When the water vapor reach the cooler air in atmosphere, it condenses and create the clouds. So the moisture from the clouds eventually falls, like a rain or snow, and filling up the seas or the river. So from the high ground, gravity will move the water from the high ground into the lower ground, and then the water cycle will continue. So hydropower is referred to as a renewable energy source because the water on earth is constantly replenished by precipitation. Okay, so our problem segment. Okay, Sabah has been popular with natural resources for many years, especially in hydrology, which has number of streams. This specificity, however, has been neglected. Other resources such as petroleum fuels, biomass and coal are more focused on by the government. Okay, this is known as non-renewable energy that is not environmentally sustainable and not durable. It will potentially have a negative effect and on the biosystem and the ecosystem. So because of the issue, we come up with the problem segment, which is what is the potential renewable energy from the precipitation. Secondly, where is the potential location of renewable energy in Sandakan, Sabah? And then how can humanity profit from this project? Okay, so next, our objective. Firstly, we want to overview of hydropower system components in hydropower plants. So second, to investigate the suitable location for building hydropower plant in Sandakan, Sabah. To analyze the risks and needs of construction for small hydroelectric power plants. to generate energy from the source of renewable energy, and lastly, to minimize the living cost and increase the benefit towards the mankind. Okay, so this is the system component in hydropower. Okay, so basically the water will go through the weir. The weir is like a tank to store the flowing water from the river, and then to maintain its flow rate. And then when the water enter through the entrance, it will go through the penstock. So this penstock is a piping system that carry the water from the weir into the turbine. Okay, before the water enter the turbine, we have the valve here. The valve is acts like a gate to control the flowing water into the turbine. So if there is needs the maintenance of the turbine, so this valve will close the water flowing into the turbine. And then when enter the turbine will converts hydraulic energy to mechanical energy, and then from mechanical energy to electrical energy. And then the water will drive back into the river through the canal, the tailways. And then from this powerhouse, the electricity will transfer to the building by the transmission line. Okay, so next, in our case study, we choose to build the small hydropower plants. This is because our location is we choose to build at the river. So there will be no dam or reservoir at there because it will cost high to build a dam, and also small hydropower is easier to use. Okay, so what is small hydropower? Small hydropower is the development of hydroelectric power on a scale serving a small community or industrial plant. It generates capacity of 1 to 20 megawatts. Most small hydropower systems are run-of-river scheme, which do not require large storage reservoir or dam. Okay, power generation from run-of-river plants is free of carbon dioxide emission, and this is one of the oldest environmentally friendly technologies. Okay, the potential of small hydropower project in Malaysia is huge. It providing a total generating capacity of 500 megawatts for long run, especially in the run of river types. Okay, so that's all from me. I will let my friend to continue.
Okay, thank you so much, Huda. Assalamualaikum and a very good morning. My name is Haida Shahira. So I will present about the literature review. So as we know, there is a lot of journal in the internet that is related to our topic. And then the first one is about the reconnaissance study to identify the micro hydropotassium site in Malaysia by Nathan Rahman and Ibrahim Hussein in 2010. Okay, next. Next. Okay. Basically, in this study show that Malaysia has a large of river network, which is that's mean there's a lot of location that can be the potential to build out the hydropower in Malaysia. So basically, the researcher in this study use they get information from the Department of Survey and Mapping and also the Malaysian Meteorological Department. So they're using two type of method, which is map studies and hydrology study. Okay, next. Okay, as you can see in this slide, this is the potential site location in our country. So let's more focusing on the meteorological station of Kota Kinabalu. So their location which is suitable in the Sandakan, Tuaran and Ranau. So the average annual evaporation rate is in 1,570.3. So basically, this is the information that the researcher get from the two department from the previous that I said before. Okay, next. Okay, we move to the journal 2, which is the environmental impact of hydropower in Malaysia in the aspect of energy, economic and environmental. So next. So basically, according to the Energy Static Handbook for Malaysia 2006, the trend of hydropower in Malaysia began to rise from a decades. So it is benefit to the Malaysia in the terms of energy power. So basically, hydropower plant, there's a few types, which is large, small, mini, micro, and also pico. This kind of type of hydropower plant is depend on the capacity of the river that can generate the electricity. Okay, next. Okay, so when we're doing some project, there will be a pro and cons. So this is a few pro and cons depending on the aspect economic, social, and environmental. For the first one in the economic, it will create a prospect for work. Okay, and then the dam will withstand for almost 50 to 100 years with the low maintenance costs and also low operations. And then from the social parts, when we build out the hydropower plant, there will be a disturbing of the housing area from the people nearby, for the people nearby. So in the future, the resettlement can occur. So next from the environmental impact, the good one for the environmental impact is there will be no pollution because the main resources is water. And also it is a clean energy that will produce by that will not produce the greenhouse gas pollutions. Okay. That's all from me, and I will pass to my next friends, Dang Surya. Thank you.
Okay, thank you, Haida. Wait a minute. Doctor, can you see this? Can you see my slide? Hello.
Hello,
Can anyone see my
I can
slide?
see it. I can see it. Just continue.
Okay. Okay. Good morning to my fellow classmate and Dr. Zainal. My name is Dan Surya, and I'm going to continue the presentation today on the methodology part. So, the first part in the methodology is the site selection. We choose this location, Sungai Kinabatangan, because Sungai Kinabatangan is the most famous river under the Sandakan division. It is the longest river in Sabah. It is also a tourist spot, and it is also a wildlife conservation center. So as you can see here at the map here, okay, this is the upper catchment. So here is the site that we choose, Barit Manis, under the Batu Putih division of the river. So the catchment area of this site is 12,300 kilometers square. So all of this information we obtained from the journal by Sahana Harun 2015. So this is also the information that we were able to gather. Between March and November, the rainfall is the greatest because of the monsoon. During April to October, the rainfall is lesser, but significant precipitation also took place during this time. So from here, we has deduced that this is the suitable site because hydropower plant, it requires continuous supply of water. So this place, it receive a lot of rainfall. So it going to have a big catchment area. So we think this is a suitable site. Okay, this is the second part of the methodology, the flow rate approximation. Okay, this is the first one that here is the rainfall intensity. So the the first one, we calculated using the Sandakan precipitation, annual precipitation. However, since we chose our site to be Barit Manis, so the annual rainfall is 2000 millimeter. So we got this as the rainfall intensity, which is 0.2 to 8 millimeter per hour. From there, we were able to calculate the Kinabatangan River flow rate, which is 155.92 cubic meter per second. So this is the last part of the methodology. Okay, like my friend Huda has explained earlier in her slides, okay, it is contain a few elements. So according to Regional Mod 2015, weir is a barrier across the river which maintain a continuous flow through the intake. So weir is essentially a tank to collect the flowing water from the river, and then the water will go through the pressure pipe and it will bring it straight to the turbine. But here at the pressure pipe, we also have a trash rack to eliminate the debris. It filter the water, and it also have a valve so that the water can be stopped for maintenance. It also the canal. The canal is connected at the powerhouse. It carries the diverted water back to the river. Okay, next, the next instrument is the turbine. The turbine is a very important instrument in a hydro power plant. Okay, a turbine converts mechanical energy to the electrical energy. Based on the journal that we have read, that we have researched, we has concluded that kinetic turbine is the best turbine because it can be used in natural bodies of water. It also can be used in both systems, whether impoundment that use them or diversion like run-off river, like our hydropower plant. So this kind of turbine, it utilize kinetic energy rather than the potential energy. So next one is the powerhouse. The powerhouse is where the generosity of electricity happen. It is also connected to the canal that I have mentioned earlier to bring back the water back to the river. Okay, last one is the transmission line. It is the conductor of electricity. It brings the electricity produced by the hydropower plant to the buildings. Okay, this is the last of my slide. Okay, this is basically the component of runoff river hydropower. As you can see here, this is the weir, the penstock, the powerhouse. Usually, the transmission line is located near here, the turbine, and this is the diagram of the kinetic turbine. Okay, that's all for me. Thank you, doctor and classmate, for listening. I'm going to let Nelly to take over from now. Thank you.
Hello, can you hear my voice?
Please continue.
Assalamualaikum and good morning to Dr. Zainal Abidin bin Asad and my fellow friends. I am Nelly Edina Medina Sarudin and I will present about result and calculation in our case study. We had decided to carry out research on the small hydropower plant using a run-off river type with a specification as follows. The elevation to a turbine 45 meter, head loss 26 meter, and we used 2.07 meter cube per second as our flow rate, as it is the average flow rate for small hydropower that can be a commercially viable site. Firstly, by using Bernoulli equation, we can cancel out Z2, pressure at point 1 and pressure at point 2 as both are in atmospheric pressure, and flow velocity at both point because the value is too small. So we get to find the head loss through turbine using elevation at point 1 minus head loss, we get 19 meter. After that, we can calculate electrical power of turbine by using the formula Q times rho GH. Q is flow rate, rho is density of water,
G is gravity, and H is head that we calculate above. Entering all values, we got 385.83 kilowatt for power of the turbine. Next, we need to know the efficiency of turbine using formula electrical power of a turbine divided by Q times rho GH, and the answer is 0.73, which means 73% of efficiency. By having the efficiency of a turbine, we then calculate the electrical power produced by hydropower plant by multiply the efficiency with electrical power of a turbine. Thus, in 1 hour, the electric produced is 281.66 kilowatt. Thus, in 1 year that the hydropower run for 24 hours, it produced 2,467.34 megawatt. To get the output income for 1 year, we multiply the power generated by 0.48 ringgit, and we got 1,056,022 ringgit in 1 year. Finally, it is clear that all the objectives in this case study had been achieved. In our case study in Sandakan, Sabah has the average amount of annual precipitation of 999.99 millimeter, but we use the annual rainfall of Barit Manis, which is 2000 millimeter. Sandakan is a deemed suitable location to build a small hydropower plant with a constant and continuous supply of water throughout the year. Hydropower is the right choice of method to produce electricity from the precipitation, since it uses water as the main source of productivity. From an environmental perspective, by building the small hydropower plant with a run of river tide, we can avoid and reduce the damage inflicted onto the environment, and at the same time, we help to grow the country's economy abundantly. Malaysia's priorities is focusing was into securing for more raw material like natural gas and coal to match with the future power generation and domestic demand, since hydropower is not a major source of power for Malaysia. However, hydropower energy has remained as an important source of clean energy in our country and will be greatly developed and improve the quality of people's life in the future. That's all from us. Thank you.
Thank you for your presentation and very good attempt from my saya rasa lah, from my thing lah. Nelly menggigil ke?
Nervous.
Okay. Our test Nelly first. Kita akan reverse Nelly first. Nelly, you said that in your conclusion you achieve all the objectives. Can you explain to me, or can you describe to me what is your objective? How many objectives you have in your case study here?
We have 5 objectives.
You have 5 objectives. Okay. For the first one,
overview of hydropower system component in hydropower plants.
so what is the conclusion of that? Overview saja. Come on, Nelly.
Where penstock panel, pressure pipe, turbine, powerhouse, and transmission line.
So the conclusion of that.
Yeah, we use all this to build a hydropower.
Okay, the last objective. What is the last objective here?
To minimize the living cost and increase the benefit towards mankind.
Towards mankind. Okay, towards mankind dekat orang-orang sanakan tu lah.
Yeah.
Okay, so what the conclusion of that?
The villagers can get benefit
From
the
power
hydropower.
generated.
Yes.
For example, kalau saya ada company, saya buat micro power plant dekat Sadakan, kemudian company itu dapat generate duit daripada electricity yang dia generate, kemudian profit yang saya dapat tu saya bagi orang kampung, macam tu ke?
We can sell the electricity cheaper to the villagers.
Okey, maksudnya kat situlah dapat keistimewaan kalau one company buat kat Sandakan, kemudian and they can sell a cheaper prices of electricity.
Yes.
Okay. It's good. Okay. You try to answer the question, but the pro rate ataupun kadar jual electricity sama rata je dekat semua satu Malaysia, kalau awak nak tahulah. Tapi no problem. Thank you, Nelly. And now Dang Surya pula.
Yes, Doktor.
Tadi Dang Surya method kan?
You method.
Saya nak tanya pasal literature review. Apa yang awak faham Haida present tadi? What do you understand what Haida presented?
Okey, daripada apa yang Haida present tu, kiranya literature review ni dia study lah apa yang kita orang boleh ambil daripada jurnal tu. Contohnya dekat sini dia masukkan 2 jurnal. Satu adalah range, berapa banyak hydropower tu dapat dihasilkan. Lepas tu dia ada bagi juga evaporation untuk Kota Kinabalu. Seterusnya tu dia ada masukkan advantage dan juga disadvantage. Itu yang setakat saya faham lah. Daripada literature review yang Haida sediakan.
Alright. So what is the related of your objective and your literature review?
Sekejap Okay, daripada Haida punya literature review tu, first dia tengok untuk kita orang punya objektif yang generate energy daripada source of renewable energy lah. Yang tu lah objektif yang tu, sebab kita orang kan nak buat hydropower. So Haida memang dia betul-betul fokus tentang kebaikan hydropower tu. Okay, kalau satu lagi tu untuk suitable location. So sebab kita orang kan Sandakan kan, Haida dia tulis Kota Kinabalu, cuma saya tak ambil daripada kat situ banyak lah, saya ambil pada jurnal lain. Lepas tu risk dan juga need tu, yang tu saya boleh refer daripada disadvantage yang Haida sediakan.
Dan sudah banyak cakap
Sebab tu saya tanya doktor.
Alright, okay. Thank you Dang Surya for your attempt.
Thank you doktor.
Okay, no problem. Good conversation. And Haida. Oh Haida.
Yes, Doctor.
Haida. Can you show me a little bit what you understand on what Dang Surya present just now? All
Dang
about the
Surya.
formula, right? No, not the formula. Yes, the formula. The formula.
Wait.
Tell me a little bit what Dang Surya present.
Okay, basically about the formula, Dang Surya dia nak tahu exactly the flow rate dekat kawasan yang kita orang dah pilih tu. So dia menggunakan formula ni lah.
Ni lah.
Yes. So melalui rainfall intensity, and then kita cari dia punya runoff coefficients,
Right.
head power dia.
Okay. So you alert lah apa yang Dang Surya buat ataupun you buat ni. Dang Surya sit je.
Part tu saya buat.
Ha?
Memang buat literature review. Part tu saya buat.
Okay, very good. Cuma saya nak komen bahagian Haida buat. Haida, if you do some literature, you cannot put whole article inside your report. Okay, you pick all the important information saja. You pick information yang penting-penting saja, kemudian you masukkan. You tak boleh.
Tapi doktor, actually report ni dia panjang lagi, so saya dah.
Ya, saya tahu, tapi tak ada orang pun buat literature review dia masukkan muka depan dia macam tu. Dia ada nama. Okay?
Oh.
Okay.
Okay, sebab saya tengok kat internet macam tu, so saya just follow je lah.
No problem sebab awak tak belajar lagi. Nanti dah tahun 4 nanti you can learn more lah about how to write a literature review in a better way. Okay? And thank you. You know what Dang Surya presented and you know what Dang Surya do. Last one, Azwatul Huda.
Yes, saya.
Azwatul Huda.
Yes,
you ada kat mana ni? Dekat awan ke?
Tak perasan guna background.
Tak apa, no problem. Saya tanya je, saya bergurau je. Okay. Huda.
Yeah.
Do you understand what Nelly present just now?
Nelly.
Yes.
He present about result and calculation that we get.
Okay.
That we use.
Tell me in deep what did Nelly calculate according to objective. Yes, based on the objective.
Objective.
Okay. Referring to what objective that did Nelly calculate?
So Nelly want to generate energy from this source of renewable energy, generate electricity.
Lagi?
Objektif ke 4.
Kamu Nelly pula. Kamu Huda.
Okay, and then from this we can know the power that we get from the equation work turbine. So the power for one day we get 385.83 kilowatts, and then 281.66 kilowatts, and then in 1 year we get 3.34 megawatts. So we want to calculate the income for 1 year.
Okay, you want to calculate the income of that turbine can produce for 1 year.
Yes.
Okay, my last question to Huda. Why do you select small power plant? You select small kan?
Okay,
ke mini ke micro ke pico? Small. Okay, why you select small rather than micro?
Because small, we don't need to build a dam, because dam will have a cost high building to the project.
Okay.
And also we choose a river. So when we choose river, it's easier to small hydropower. Hydropower is easier to use at the river.
Why not mini?
Because we want to generate the flow rate is to generate 10 to 20 kilowatts.
So
we choose.
So the capacity.
For small.
The capacity stable for the power plant is small, not mini.
Yes.
Okay, that's good answer. Thank you. Group number 2. Thank you.
Thank you, Doctor.
I think that's good question and answer session for me because you can answer even though you nak answer lah. Tapi that's good. Thank you sekali lagi. Jangan lupa upload you punya PowerPoint and we can start with group number 3. Thank you again, group number 2.
Thank you, Doctor.
Alright.
Thank you, Doctor.
Group number 3, please. You may start when you're ready. Okay? I leave it to you. Right now.
Ya, Doktor. Doktor dengar, Doktor?
Can you start now, please? Adiba punya mikrofon tu. Siapa yang nak present first ni?
Syakti, Doktor.
Syakti, okey.
Rasanya internet dia macam slow.
Okay, can someone help her present her part?
Ya. Doktor dengar tak?
Okay, I hear you. You can start.
A very good morning to Dr. Zainal and yes, Doctor. Okay, very good morning to Dr. Zainal and my team members. Today, we would like to present our case study regarding the generating electricity from recreation waterfall Kota Tinggi. And here, I myself, Shaktishri Dr. Subramaniam from ERT353 Biosystems Engineering. Today, we would like to start the presentation with the introduction part. Okay, we would like to present our first slide. Okay. I would like to start the background from the electrical energy. Electrical energy being the fundamental driving force for a country's development. So a country's demand for electrical energy is purely dependent on the population, number of population of this country. Let's say the population of that country is high, the demand for electric energy also will be high. And due to the development on this 21st century, all correlated with this electrical energy. So the energy source, sustainable electrical energy source for a country will be promising the development of that country. And that is why for making the electrical energy source sustainable throughout all the time, we need to find a renewable energy source. And we have many choices of renewable energy source like hydro energy, solar energy, etc. But today, my group will be focusing on hydro energy. And why hydro energy? Because, right? Because the topic we have given is generating electricity from waterfall. Water is hydro. That is why we selected hydropower. And in our Malaysia, the portion of hydropower that is being used to generate electricity is just 11%, and it is a small value compared to many other countries. And the key study area that we selected is a recreation waterfall that is situated in Johor. And the waterfall is 36 meters high, and it is located at the base of Gunung Montaha, and it is also 15 kilometers away from the Johor Bahru site. Okay, what is the problem that we face that leads to this case? This recreation waterfall could be the favorable destination for tourism, not only in Malaysia, but also for many other foreigners. And that is why many resorts, chalet, hotel have been developed near the waterfall. And here I show you some of the examples of waterfall resorts that, resorts and chalet being developed in that particular case study area. And that is why the demand for electrical energy consumption in that particular area is very high. And using the electrical energy from that normal energy source wouldn't be that enough for that particular place. That is why we need to find renewable energy source that can that can help to making the electrical energy source sustainable throughout the year. And waterfall is the main source of water, and that is why we're proposing a small hydropower that can generate electricity from the moving source of water. And why small hydropower? Because it is low in cost in terms of construction, also maintenance, and also it is environment friendly because it is not using any other fossil fuels to generate electricity. Next slide. Okay, what is the significance of study? This case study will be very useful in future purposes because most small-scale hydropower projects must be built in Malaysia, and also we can compare the electrical usage in terms of the normal usage and also using the small hydropower in terms of cost, maintenance, also the power it produced per hour and also annually. And also, we can have an alternative electrical energy source because let's say we have facing any problem with the normal usage of electrical energy, so we don't have to hesitate to face the problem since we already have an alternative renewable energy source to generate the electrical energy that we are needed in our daily routine. Next slide. So for our case study, we came up with three main objectives. First is to design small hydropower plant utilizing the optimal energy in the water. with the minimum terms and economic cost considering seasonal change to meet the user's demand in all the year. And also the second objective is to harvest electricity resource and for sustainable water and energy development. And our third objective is to reduce the conventional fossil fuel power usage with an alternative hydropower technology. And that's it from today. I would like to pass it to Nur Adiba, my friend, to continue the presentation.
Okay, thank you, Shakti. So today I will continue my part. My name is Nur Adiba. So I will tell you about literature review. So the first is introduction. In 1849, the first modern water turbine developed by engineer James Francis, which is the British American engineer. And then in 1890, Lester Allen Pelton developed patent wheel, which is patented in 1880. Lester Allen is an American investor. So in 20th century, Victor Kaplan developed Kaplan turbine. So the next is I will tell you about the types of hydropower turbine. So there are two types of hydropower turbine, which is impulse turbine and reaction turbine. So in impulse turbine, there are Turgot, Pelton, and cross flow. So I will define the impulse turbine. Impulse turbine is use kinetic energy of water to drive the runner and discharge to atmospheric pressure. Runner of impulse turbine operates in air and it is moved by jets of water. In reaction turbine, there are three types of turbine, which is propeller, Francis, and kinetic. Reaction turbine generate electricity from the mutual action of the pressure and by moving water. And it is operate when water is fully submerged in water and is enclosed in a pressure casing. So next I will tell about gap of study. In my gap of study, there are three parts, which is I will tell about the design, the advantage or the disadvantage of this research study and the result or conclusion. So the first research paper is a review of small hydropower technology. It states that the fundamental elements of small hydropower site characteristics are weir, settling tank, which is a 4 bay, penstock, and small cannon. And then the advantage is long-lasting and robust technology, can last for years without major new investment, produces no atmospheric pollutant and only few GHG emission. The disadvantage is required multidisciplinary involve modification of aquatic habitat only for rural area. The next research study is optimal installation of small hydropower plant. It states that small hydropower schemes are water taken from the river by diverting it through an intake weir. Water passes through a desiccating tank. Water slow down for suspended particles to settle down before flow to the turbine. Water is carried to 4 bay by cannon in medium or high heat installation, and then penstock conveys water from the 4 bay to turbine. There is a valve or gate at the top of the penstock. So as for the result, optimization of cost in speed control can be achieved by use of electronic sensor rather than conventional method. And then cost reduction for turbines can be achieved by use of reverse prime movers rather than going for separate turbine and pumps. As a conclusion is the ratio study. Small hydropower plant developed in the area of optimal installation. Number of contribution exists to determine the installation cost using the head and capacity as cost influencing parameter. The last one research paper that I take is small scale hydropower as a source of renewable energy in Malaysia, which is a review. So it states that basic system of typical small scale hydropower plant are water supply, penstock pipe, turbine equipment, electronic controller, distribution system, and electrical load. As a result, in Malaysia, small scale hydropower is the most effective option for electricity generation for society who are living in the remote area. Other than that, it's able to generate electricity and to be implemented in location where the water head is low. Thus, its power output from turbine depends on the dimension of the wheel, speed, and flow rate of water. Instead, the advantage of this small hydropower are easy operation and maintenance, ideal energy solution for any country's sustainable development, such as loss of land, relocation and animals and humans change in ecosystem. The advantage are renewable energy are not well established. Some technologies still under research compared to the conventional energy. So the last part is our main concern in our case study. So instead we have four main concern in our case study, which is type of turbine to be used, flow velocity, annual rainfall in the area, and flow rate. So for type of turbine to be used, we have to choose the turbine that can generate enough electricity to the area in waterfall at kota tinggi. So for the velocity, it gives influences to the performance of the turbine, and the flow rate, turbine rotor design, water head affect the turbine performance. For the annual rainfall in the area, if the area doesn't have annual rainfall, the construction of the hydropower will suffer losses and will not give benefit to the resident at the area. So that's all for me. I will pass it to Aiman. Thank you.
Okay, Assalamualaikum. Dengar Doktor? Okay, Okay, my name is Muhammad Aiman bin Rizal. We start the slide from methodology. So material and instrument used is to the proper small hydropower project for kota tinggi. Waterfall usually use material, a water intake, a weir, a penstock pipe, a turbine, and a powerhouse. For the next slide, penstock pipe. A penstock pipe is an enclosed pipe that supplies hydro turbines and sewerage system with the water. Or a penstock pipe is an intake structure that regulates the flow of water. So for our design, we use a steel pipe with size 15 cm diameter. So next slide. Next is turbine. So hydro turbine are machines that transfer energy from moving water to a rotating shaft to produce electricity. Turbine will start rotate with the pressure from the water. So the turbine is installed height 50 meter below from the water in weir. Next slide is a generator. For the generator is in turn connected to a substation where the energy produced is transformed and passed on the grid. So next is head measurement. At the right side is a picture of a device is used to measure the head of the proposed powerhouse site. This device is based on electronic bearing sensor and barometric sensor technology. This device also can measure up to 90,000 meter in height. This uses is the altitude taken at the location where water intake and at the powerhouse. From there we will find the gross head. Okay, for the next slide is flow velocity measurement. It used in open channels such as river. This system is designed for calculation flow velocity. Based on the scale attached to the probe itself, it can calculate the depth of the river. Now we go through to the calculation. From the table, for the reference, we have height, water at top 50 meter. We use a steel pipe, roughness is 0.0015 millimeter, and the size diameter is 15 centimeter. Length pipe is 20 meter. Flow rate is 2 meter per second, and dynamic viscosity at 25 temperature for the river. And the areas at the location is specific is 2 meter square. So first we find Reynolds number. The equation is rho time velocity time diameter per dynamic viscosity. So for the conclusion, we get the turbulent flow that was higher than 4,000. After that, we using the Colebrook-White equation that find the friction factor. Then we use the roughness in the equation. So we find we get that his friction factor is 0.014. Next slide. Then we use the Darcy-Weisbach equation where the head loss is friction factor time length time velocity square per 2 diameter time gravity, and get the head loss is 0.38 meter. After that, we find the flow rate Q. So from the Q, we use area time velocity. Area is 2 times with 2, we got a 4 meter cube per second. Next is Bernoulli equation. Use we can cancel the pressure because at the both side is the open channel. So that velocity the both side have the same velocity, we can cancel it. Then we get elevation times head turbine and head loss. So from this we can find the head turbine where 50 meter minus 0.38, that we get 14.62 meter. Next, after that we can find the work turbine where the formula is flow rate time pressure. So pressure we can same with your rho GH turbine. So for the work turbine we get 573.7 kilowatt. So if the efficiency from the turbine is 75%, so we can get the work electric is 430 kilowatt. That's all from me. Thank you. I will pass to the Siti Zulaika.
Assalamualaikum and good morning to Dr. Zainal Abidin Arsad and my friends. So I will present the result and discussion of the case study of hydropower plant in Kota Tinggi Waterfall. Based on the research, area estimated at the waterfall area is 79.80 km square. The sources of the waterfall, Kota Tinggi Waterfall, is from Sungai Pelepah at Gunung Muntaha. Water catchment area selected for this measurement for the case study is 2 meters square. We use the turbine efficiency which is at 75%. With the calculation of Bernoulli equation, we can find the power output, and based on the turbine power, we can calculate the power output, which is 430 kilowatt. Based on the power output generated that we estimate, the value is under hydropower scheme, which is a small hydropower, which is a mini hydropower with capacity of less than 1 megawatt energy power. Next. Turbine is a device used in hydroelectric generation plants that transfer the energy from moving water to a rotating shaft to generate electricity. From our case study, we choose Pelton wheel type based on its head and flow rate value estimated. Kota Tinggi Waterfall scheme is estimated to generate more than 200 kilowatt, which is at 430 kilowatt. Pelton type is suitable turbine can be used, which is the kinetic energy of the water is used for the rotation of the impeller. Then the water accelerated and ejected from the surface of the Pelton pedal will provide a rotational speed of the turbine. Then it is converted to electrical power. penstock, which is a pipe or long channels that will be carrying the water down from the hydroelectric reservoir to the turbines inside the actual power station. We use the steel material as because it has lower strength. Still, since it is a small hydropower, it is watertight and lasts long material that can be used and less expensive. Usually, we use to store turbine and power generator at the powerhouse, which is located above water level to prevent flooded powerhouse, since the precipitation at Kota Tinggi area is very high, which always cause a flood. So the powerhouse constructed will be in a firm foundation, easy access, and have slope protection and drainage that is suitable for our case study. Next. For equipment cost and the cost of energy estimated, we can see that there is cost and energy for our equipment, which is turbine, penstock, powerhouse, electrical dam, gravel trap, cabling, maintenance, miscellaneous, annual cost, annual power generation per year, and cost of energy. Based on our research and our estimated calculation, our annual cost for hydropower, the cost of energy is at 0.08 cent compared to Tenaga Nasional Berhad tarif value, which is at 40 cent. The annual power generated per year for hydropower scheme is 3,360,960 kilowatt per hour compared to TNB annual power generated per year, which is at only 1,569,500 kilowatt per hour. After being calculated, the annual cost for hydropower scheme is RM268,877 per year compared to TNB price, which is more than hydropower electrical generated, which is at RM490,096.80. That's all from me. I will give my friends to present the conclusion.
Who will present this conclusion?
Sorry doctor, actually this part is Shakti will present it, but I will take the part. So in conclusion, Recreation Waterfall Kota Tinggi, Johor could be forthcoming site for small hydropower generation. By suggested design, penstock steel pipe, turbine pattern V type. For turbine efficiency, which is 75%, and annual is 3,360,960 kilowatt per hour, and the lowest tariff is 0.08 cent kilowatt per hour. So small hydropower recommended that reduce environmental and social problems, low cost for facility construction and equipment installation, and most economic renewable energy, very easy and cheap operation, short period of construction, and can supply generated electricity to remote area directly. So that's all from me and our group. Thank you.
Okay, thank you. Adiba, who's made that conclusion? Who's
Shakti.
Shakti, okay. So
Shakti
awak bagaimana awak buat, Adiba?
Saya.
Literature review.
Aha.
Okay. From that conclusion, saya tak nak tanya yang awak buat, saya nak tanya yang orang lain buat. Awak faham ke tak?
Okay.
Okay.
Boleh.
From that conclusion, what is that lost cost? Lost cost there.
Lost cost.
Cuba tengok dekat slide awak. Lost cost.
Okay, ha.
Apa benda tu?
Sabar sabar.
Cuba buka balik slide.
Ya, sekejap. Yang mana doktor?
Dekat conclusion tadi, nampak ada lost cost of installation apa benda tu.
Ni kan pusing lah ni.
Mana saya tak nampak pun.
Oh ni. Tapi Zen lah. Okay, sekejap.
Apa benda tu? Apa benda yang
Oh,
hilang?
bukan loss. Sebab tu low cost.
Okay, low cost. Okay.
Low. Silap.
Okay. Low cost. Macam mana boleh kurangkan social problem? Reduce social problem kalau you buat hydropower dekat situ. Apa masalah dengan social problem? Macam mana boleh reduce social problem? Soalan kedua saya untuk Adibah.
Oh, banyak soalan untuk saya. Sebab kejap doktor. Mana hilang?
Jawab je apa yang awak cross your mind. Pakai logik je. Tak perlu nak cari-cari. Macam mana boleh
sebab kawasan tu bila kita dah buat hydropower tu kan, mungkin kawasan tu mungkin akan macam kurang pengunjung.
Okey. Kurang pengunjung.
Kurang pengunjung.
Okey.
Sebab kawasan tu separuh kita dah ambil untuk kita buat yang small hydropower tu kan. Jadi benda tu dah kurang pengunjung, so macam social problem tu kurang lah.
Apa? Okey, sorry Adibah. Saya awak waterfall kan? Kota tinggi tu waterfall kan? Ni tempat orang datang ni. Dia nak mandi-manda, kemudian awak buat power plant lah. Power plant, hydro power plant. Kemudian itu tujuan dia, saya nampak kat situ macam awak nak bagi electricity lah kat kawasan-kawasan penduduk situ. Betul? Okey. Tapi dekat conclusion awak tulis dia boleh reduce social problem. Bila awak buat hydro power plant tu, macam mana dia boleh reduce social problem?
Saya tak sure lah part tu doktor.
Okey. So awak biar Syakti buat seorang-seorang lah ni.
Tak, saya kopas baca semua. Slide pun saya yang buat.
Okey, tak apa. Terima kasih Adibah. Adibah tak boleh jawab. Kita teruskan dengan Zulaika. Bukan. Aiman. Bukan Zulaika, Aiman.
Ya, saya doktor.
Aiman.
Yes.
Based on Zulaika present just now, I can see the graph. You select the graph of turbine. Which one of turbine you want kan? Based on what? Based on what value do you select that turbine? Adibah boleh tunjuk sekali Adibah. You punya slide tu.
Yang mana?
Yang bagian Zulaika.
Result and discussion tu. graf turbine.
Ya, ada banyak-banyak turbine tu. Tu tadi.
Tadi.
Ni. Based on what data you referring to? Because you need you select a Pelton type, right? Based on what data you select as a Pelton type turbine for your hydropower?
Daripada kiraan di mana kita dapat head dia tinggi, lepas tu flow dia kita ambil yang dah kira tu dapat flow velocity mana 4 meter cube per second. Lepas tu dengan work turbine dapat generate tu dan around 400 kilowatt. So kita orang dia punya graf tu dapat dekat Pelton.
Pelton turbine lah. So head you kira macam mana?
Head kira menggunakan measurement tadi.
Measurement device.
Apa?
Measurement device tadi. So you punya head dapat berapa?
Dapat 15 meter.
15 meter. Kalau 15 meter dekat, dia bukan Pelton lah. Betul tak? You punya flow rate berapa? 4. Cuba tengok kat bawah tu garis X untuk flow rate, head untuk axis Y. Agak-agak lah 4 kat situ, straight ke atas, vertical. Kemudian you punya head berapa? 15?
Betul.
Head 15. Cuba cross, dia dekat mana?
Dekat kaplan pun boleh.
Ya, sama ada cross flow, kaplan. Dua tu lah. Cross flow ataupun kaplan. So, kenapa select Pelton? Ni bukan nak marah ni, tanyanya. Jawab aja. Sebab saya suka Pelton. That's it.
Pelton. Sebab kita orang fokuskan kepada impulse turbine.
Impulse turbine. Okay. No problem. Thank you, Aiman, for your answer. Now, Zulaika. Are you there, Zulaika?
Yes, Doctor.
Zulaika, please explain to me what Adiba did for literature review.
For Adiba part just now, Adiba talk about the literature review.
Okay. Adiba tak payahlah, biar je lah. Orang tu cakap, awak tunjuk slide. Boleh lah orang tu nak jawab sikit.
Literature review, Adiba talk about the types of hydropower turbine, which is it has two type of turbine, impulse and reaction turbines. Our selected turbine is under impulse turbine. We choose impulse turbine where it has also has pros and contra, and there is also a research that say that even though the power generated can be used for other turbines such as cross flow or Frenches, but Pelton turbine also can be used by using a head at 15 meter. So refer to the bar slide just now.
the impulse turbine is Turgo, Pelton, and cross flow, and the reaction turbine is propeller, franchise, and kinetic. And there is also a difference between impulse and reaction turbine, which can give pros and contra for our hydropower generator.
Okay, Zulaika.
Mm-hmm.
Is there any justification why you still use a Pelton instead of cross flow and the other one? What the other one on your graph just now? Is there any justification why you stick to Pelton turbine?
In my opinion, there is no problem if you use Pelton turbine, since there is also a research where even though it is a 15-meter high head, we can still use Pelton, which the Pelton turbine it use a nozzle with a different diameter of nozzle. So if you use for 15-meter head for Kota Tinggi waterfall, we can adjust the nozzle so the flow rate can be decreased or increased.
So what is the impact if you still stick with the Pelton? What is the impact? If you still choose to select a Pelton turbine for your project instead of cross flow and the other one, what is the impact? Is there any impact? No impact.
The impact is it can still works for low discharge or low flow rate. Even though it has a low flow rate of discharge of the water based on the precipitation, we can still use Pelton turbine. And the turbine, the maximum efficiency is 90%, which we are using 75%, so there is no problem if you use Pelton turbine.
So there's no impact. Soalan direct tu Zulaika. No impact or there is impact?
There is impact.
There is impact. Okay. The first impact?
Impact to the water discharge.
Impact to the water discharge. Apa terjadi dengan water discharge tu lagi besar?
No, the water discharge if you use Pelton, since it is 15 meter, so kita nak pakai pump, kita boleh install pump juga untuk lajukan dia punya flow rate.
Okay.
So
you need extra head lah nak gerakkan Pelton ni. Kalau awak balik semula dekat graf tu, Pelton dia bergerak pada head yang tertentu. So kalau awak tak tambah head, maksud saya tak lajukan flow rate dia, so Pelton awak tak bergerak. Itu impact dia. Okay? Kat sini. Tadi awak punya lebih kurang 15 saja kan? Pelton dia berpusing start 50 meter head. Kalau tak cukup 50 meter, Pelton turbine awak tak bergerak. Okay? Faham yang tu? Okay, the last one. Kalau Shakti punya internet tak ada problem, you can answer this question. Tell me the continuity of your objective and conclusion.
Yes, Doctor. Okay, the objective for our case study is main three objective. So the first objective will be to design a small hydropower plant utilizing the optimal energy in the water with the minimum submergence and economic cost considering seasonal change to meet the user's demand. And if Doctor see our conclusion,
okay,
we achieved the objective because the objective we want to focus is to design a small hydropower with the optimal energy in the water and with the submerged economic cost. So we already mentioned in the objectives that we reduce the environment and also the low cost for facility construction and equipment installation. That is why we mentioned the submergent and economic cost. And for the second objective, to harvest electricity from renewable energy source for sustainable water and energy development, it also achieved because we can harvest electricity throughout the year with the renewable energy source, which is the hydropower, with the sustainable water, because waterfall is sustainable water flow and energy development. And also the third objective is to reduce the conventional fossil fuel power usage with an alternative hydropower technology, because hydropower is fueled by water, and so it's a clean fuel energy. Of course, it won't pollute the air like a power plant that use fossil fuels such as coal or nature gas. So with that, we already achieved the third objective also.
Okay, you straight to the point. What my question is, so no problem. I think this is one of the best group for just now. Untuk sekarang kita group 3 kan, one of the best group. Saya dah baca juga a little bit on your report. That's good attempt, I think. A lot of covered. Of course, I didn't expect that you can come out with that figure, turbine figure. I didn't expect that you come out with that figure. So you come out with that. So I think this a lot of depth study in that. No problem. That's good. I can classify it's excellent. Okay, thank you. Group number 3. Okay.
Doctor, sorry for the inconvenience just now. The internet.
No problem, no problem. Okay, we can continue with the group number 4.
Doktor,
Yes.
saya tanya soalan boleh?
Tak boleh, tak ada masa.
Tak boleh.
Tanya mesej je, mesej. Kita tak ada masa lah, Adiba.
Okay, tak apa.
Okay, sorry Adiba.
Thank you, Doctor.
Thank you, Doctor.
Okay. Group number 4, I think it is Group Atika, harvesting electricity from wave in Port Dickson. Please take a floor and start now. Mula. Najiha, Fatin, Fatul dengan Atika, tak silap saya. Please start immediately, okay? We don't have a time.
Guna phone. Kejap, Doktor. Then now. Ini kok macam tu. Select. Oh, tu.
Lekas.
Tak tahu buat apa je lah. Buka kat ni.
Lekas, lekas.
Ayo wabarakatuh. Doktor dengar?
Dengar, dengar.
Assalamualaikum warahmatullahi wabarakatuh and good morning. My name is Fatih Azura binti Sabaruddin. I'm from Group 4 and today our group will present about harvesting electricity from wave in Biosystems. Okay, our location of study is Biosystems, and Biosystems is a famous beach resort town located in the district of Biosystems, Negeri Sembilan. Biosystems is located on the seafront. It has area and 140.32 square kilometers. The area is divided into two, namely the operation of 35.87 square kilometers, while the control area of 104.45 square kilometers. The area of downtown Port Dickson is 395.5 acres. Next, based on preliminary study on wave energy were conducted in the 1920s and in the early 1980s. The waves resulting from the wind blowing. The size of wave depends on the wind speed, the period of time wind blow to generate the wave, and the distance the wind blow to the wave. Wave energy is another type of ocean-based renewable energy source that use the power of wave to generate electricity. Wave energy generation is not widely employed commercial technology compared to established renewable energy sources such as wind power, hydropower, and solar power. And these are our objectives. First is to identify if condition is suitable for harvesting waste energy. Second is to study about device to harvest waste energy. The next slide before we continue.
Okay, Assalamualaikum and a very good morning to our lecturer, Dr. Zainal Abidin bin Arshad, and to all my friends. I'm Ifatul Mahir bin Muhammad Asri from Group 4. I will continue this presentation with my part is review in harvesting electricity from waste in pollution. As we know that the wave energy is come from ocean. As we know that ocean cover half area of Earth, almost two-thirds of the Earth's surface. Ocean water is a mixture of star and gases. Ocean is a thin film of water and its average depth is 3.73 km. Ocean floor is not flat and stable. So based on journal Ocean Wave Energy Harvesting that written by Niti Kumar Singh in 2014, he was said that ocean is an enormous source of energy in the form of wave, tidal, marine current and thermal resource. It has a great potential to fulfill the demand of electricity. Next slide. Next slide. Okay, this is available energy resource. For salinity gradient, it shows that the energy created from the difference in salt concentration between two fluids, which is ocean and water river. For the second one is tidal energy. Tidal energy is power produced by the surge of ocean water during the rise and fall of tide. Okay, for the third one is marine current. Marine current is a form of marine energy obtained from harnessing of the kinetic energy of marine current, such as the Gulf Stream. For the thermal, energy, it's due to temperature difference between surface and deep water layer. Thermal energy can be captured using ocean thermal energy conversion system process. We call it as OTEC. And the last one is wave energy. For the wave energy, kinetic energy and potential energy associated with ocean waves can be harnessed using modular technology. Okay. So, as we know, wave energy conversion device can be located on or offshore. Mainly 4 types of wave energy technologies exist. For the first one is attenuator, point absorber, overtopping terminator, and oscillating wave column. Based on the research of model testing of an ocean wave energy system from formulation C by Omar Deyakko. Omar Deyakko is from UTM Johor. He was said that one suitable type of wave energy device that can be used in Malaysia is oscillating water column. So, what is oscillating water column? Oscillating water column is a shoreline device. It works on variation in air pressure enclosed by column. Due to rise and fall of waves in column, air alternately compress and depressurize the air inside column. This compression and expansion of air pressure drive generator for producing electricity. Pressure inside column varies as a function water level. Higher the water level, greater will be air pressure. Next. Next. Okay, this is a basic principle of oscillating water column. slide tadi yang sebelum. Okay, this is basic principle of OWC. It has a water column, front wall, wheel direction, well turbine, generator and back wall. Okay, based on Nishiko masking, oscillating water column has three types. For the first one is LINPAC, stand for land installed marine power energy transformer. For the second is ocean energy buoy, and the third one is OWEL. OWEL is stand for offshore with energy limited. Next. This is different system, energy etc. and such types of oscillating water column. So we was choose LINPAC as a suitable device to use in this case study. Next. Next slide. Okay, why we choose oscillating water column? This is based on Omaya Cook in March 2013 in the research of model testing of an ocean wave energy system for Malaysian sea. He was said that Malaysia is situated at an equatorial and surrounded by sea, and currently this free power from the ocean is not given full attention by the Malaysians. Burma has shown the possibility of harvesting this precious energy to be used in Malaysia by utilizing several types of wave energy device which can extract energy from wave in Malaysia sea areas. One suitable type of wave energy device that can use in Malaysia is oscillating water column. So, Fatih Hazira will continue this presentation.
For turbine design, we choose a turbine. There are three types of turbine normally used in OWC, such as impulse turbine. An impulse turbine is turbine that is driven by high velocity jet of water or steam from nozzle direction on the flange or bucket attached to a wheel, and it has efficiency less than 40%. Second, for well turbine, the well turbine has the remarkable property of rotating the same direction regardless of the direction of airflow in the column. The efficiency of well turbine is between 40 to 70%. Carbonese turbine, second is carbonese turbine. It has a simple construction of operation independently of the direction of the wind and start at low wind speed. It was developed and it has maximum efficiency about 51% only. Based on the type of turbine, we can see that the turbine has high efficiency compared to the impulse turbine and synchronous turbine. Well turbine also most efficient at low speed at flow.
So wind turbine is more suitable used in OWC. Next. Okay, Assalamualaikum. My name is Nurul Atifah binti Muhammad Nasir.
Ya, betul technical issue ya grup ni. Padahal grup nombor 4 ni. Atika. Hello. Halo. Fatin. Halo. What happened?
Kerja doktor ada masalah teknikal sikit.
Apa masalah? Masalah apa?
Okey doktor. Okay, sorry untuk masalah tadi. Okay, Assalamualaikum. My name is Nurul Atifah binti Muhammad Nasir. Okay, you can see this is the example of the fixed type of the oscillating water column. It's usually built on the post. Okay, that's a symmetric outlet of OEDC pipe. It has two main components for this principle. First is reinforcement concrete chamber, and second is turbine generator. Okay. The power take off for this technology, we use a turbine. The most commonly used air turbine for this application, the well turbine. The water level in the chamber rise and use the return of the wave and arc aspiration. The air is compressed inside chamber. Inside it, the air force forward and backward through the turbine for the rotation turbine. This generates mechanical energy that is converted into the electricity by a generator. Okay, the well turbine has a special feature. It always rotates in the same direction regardless of which direction of airflow come from. How is this possible? Okay, it is possible because of the symmetric shape of the rotor blade. The symmetric blade. Okay. The air hits the rotor blade in the possible direction due to the symmetric shape of the rotor blade. The same effect when the airflow comes from the other direction. Therefore, this turbine always rotate one direction regardless of the airflow direction and guarantees the continuous rotation of the turbine. The well turbine must be written on initially. The airflow alone does not change into rotate. So this well turbine this turbine is the one of the simple turbine for wave energy conversion. It has very few moving parts, no part in no gearbox, and easy to maintain. Has efficiency around 40 to 70%. Okay, this is the principle of the wave energy that we use in our study. To find the frequency, velocity, flow, velocity of that water, and movement. Okay, this table shows example of the wave data which we got from the windfinder.com. Okay, from the wave data from windfinder.com, we summarize the data to see the height and the wave period for each day. Based on our study for 10 days, the average wave height in position is around 0.1 meter and the average wave period is 2.6 seconds. From our study, this is the data of the wave power. We choose to use 6 modality points to generate power in position, and we use a maximum efficiency for well time is 70%. Okay, I will continue with the Astra. And my name is Najib Abdullah. So, the energy generated on average can be distributed around 2,184 houses in the Port area for 10 days. About 158 houses per day. So, the energy consumed by each household was about 25 kilowatts per day. So for the result and discussion, so the figure shows the data we calculated for 10 days. It's the graph of wave height versus gain. So as you can see, among the 10 days on 5 January has the highest wave height. It's because the wave depend on the wind speed, tidal state, and the amplitude. So the wind speed on 5 January was the highest, which is 4.25 knots. So next graph shows wave period per day. The wave period and wave height are independent parameters. As wave height increase, the wave period also increase. So the frequency wave refers to how often the particle of the medium vibrate when wave pass through the medium. So the highest wave period is on 5 January and 6 January because it has the lowest frequency, which is 0.33 seconds. So the next is the figure shows the differences with height in Kata, Japan, and the Philippines, Malaysia. So from our study, we found that these two countries use the same system, which is the wave power generating system within the well turbine. It consists of chamber, turbine generator. As you can see, it has a big difference of wave height. In Japan was higher as what we said. The wind speed in Japan was 90 knots, in Malaysia only. The shape of the plays a role for the wind speed for generate the power. So this is the map of the data in and the map of policymaker. So you can see that the support doesn't have the other country that block the wine, so it has the highest wine speed rather than the pollution in Asia. So the power generate that we calculate for one day we got 64,671 kilowatt per hour. For 1 month, 1,940 megawatt, and for 1 year, 23,280 megawatt. So for the conclusion, we made that pollution is not a suitable place to make with energy. This is because pollution policy is protected from the wind in other countries. The pollution also is a tourist destination where it is always full of people. So for the maintenance of the well turbine, it costs a lot of money and it emits lot and noise to disturb the people there. Thank you.
For your uneasy presentation, can I say like that? Uneasy presentation because a lot of technical error. There's only one question for your group. Okay, there's only one question for your group. Please tell me, Ifa, why exactly your conclusion is not suitable? Why your conclusion is your hydropower plant, or not hydropower plant, your electricity generator is not suitable for Port Dickson location?
Sebab Port-Dickson ni kita tahulah Port-Dickson ni satu tempat yang pelancongan kan.
Baru saya tahu, awak bagi tahu saya baru tahu.
Kira tempat pelancongan. Lepas tu kami pengunjung kalau kita bangunkan wave kalau kita buat tempat untuk generate electricity daripada wave tu, kita akan pasangkan banyak device kan. Lepas tu device tu kemungkinan dia akan mengganggu pelancongan dekat tempat tu lah. Lagi satu, daripada kajian ni kita tahu untuk bangunkan wave ni, wave energy plant ni, dia melibatkan kos yang tinggi lah, kos maintenance yang tinggi. Lepas tu benda tu dia akan macam bising lah, akan mengganggu ketenteraman pengunjung-pengunjung dekat Port Dickson tu.
Okay, can it generate power? Can it generate power if you still want to install in the Port Dickson? Soalan saya bukan kepada Ifah, soalan saya kepada Tintin.
Boleh, tapi dengan power yang di-generate tu 10 kV.
Boleh, Doktor.
Atas alasan?
Tapi tak berbaloi lah sebab harga untuk bina device tu pun dah dalam 30 million.
Nak buat 30 million. Kemudian power yang generate
tu
dalam apa? Dalam rumah ke?
nanti tu
berenang.
Sorry Fatin, apa?
So, gawat.
Okay, so tak berbaloi lah. Okay.
Ya, harga tu pun dalam 1 tahun dapat banyak tu.
Alright. Okay. So, untuk reasoning dia macam tak berbaloi lah. If you put oscillating power kat situ kan, generating power kat situ, okay. But however, good attempt saya rasa untuk group awak ni. Good attempt. Awak berada kat audition rupanya. Good attempt. Sebab group ni 2 kali jumpa saya. Sebab tak tahu nak buat apa langsung. Tanya, you made the report and you made some progress on your presentation. That's good. There's a lot of apa saya nak beritahu, uncertainty lah dekat you punya report, but it's okay. It's just a try and error and attempt for a report. Good effort. Thank you for group 4. Next, for last group number 5. I hope that you are always ready for group number 5. You are group last. Please start now. Yes, I can hear you.
Yes, sir.
Okay, you may start when you are ready. Who will present? Please, quick.
It's finding the slides. Okay. Good morning. So you can hear me?
You. Please
Okay,
start.
can you hear me? Okay. Good morning to Dr. Zainal. We are from Group 5. We'll be presenting about harvesting electricity from wind in Putrajaya. Next slide. Okay, I'll be starting by giving introduction about our topic. Okay, first, the climate in Putrajaya is hot, oppressive and overcast, as we already know Malaysia's temperature. So Putrajaya is the business capital of Malaysia, which is 25 km south of KL. Kuala Lumpur, which serves as the federal administrative center of Malaysia. Its geographical location is 255.6 north to 10141 east, and the time zone is 8. So the area within 2 miles of Putrajaya is covered by cropland 85%, within 10 miles by cropland 63% and tree 18%, and within 15 miles by water and trees 36% and 32% respectively. So over the course of the year, the temperature typically different from 23 degrees Celsius to 33 degrees Celsius. And over the past few years, renewable energy continuously has been in high demand with percentage of over 30% per year, especially in those business capital areas like Putrajaya as very high demand for electrical production. Right? Electricity can be harvested from wind turbine where they require appropriate wind speed. Next, I will present about the problem statement. Okay, from our survey, we found out the wind in Putrajaya does not fulfill the requirement. Because the amount of energy generated by a wind turbine depend on wind speed, the areas swapped by the blades and air density. The wind speed that produced in Putrajaya is at minimum, which is within the minimum wind speed should be 12 to 14 km per hour, which is 3.33 meter per second to 3.8 meter per second. As next one, as you see in this figure 1, it shows average wind speed in Putrajaya for a year, and the highest shown in January and December, which is from 3.0 to 3.5, which is in the range of minimum wind speed production. So back again. Again, problem statement. So you can see that it does not enough for the wind turbine to produce enough electricity in Putrajaya. So next is the wind speed is not consistent, as you see in the previous figure that I have shown. The wind speed drops drastically from January to April, which means it's not consistent. It goes down, up, down, and up. It's not consistent at all. For a production of electricity, wind speed consistency is very important. Problem statement. Problem statement. Okay. And temperature in Putrajaya also plays an important role for the production of electricity, because when the temperature is high, the air pressure and air density will be very low. Actually, there's a range for air density, which is between range for air density for the electricity production. The temperature should be within 20 degrees Celsius to 50 degrees Celsius for the wind turbine to work regularly. So as you see, the temperature in Putrajaya is going above the minimum, which is 20 degrees Celsius, and also lower than 20 degrees Celsius in some months. As you can see in figure 2. The temperature is above 20 for 8 months only. Apart from that 8 months, the rest the rest 4 months is very low, lower than 20 degrees Celsius. So this could affect the air density. It could affect the wind turbines for the wind turbine to produce electricity. And apart from that, when the temperature shouldn't be very high, because if the temperature is very high, it can lesser the energy output. And also it shouldn't be very low, because if it is low, the blades or any parts in the wind turbine can froze and can affect the wind turbine, the function of wind turbine. It might stop the wind turbine. Problem statement. Lastly, electrical obtained from non-renewable energy affect the environment because nowadays we are using fossil fuel for the production of electricity. So using the fossil fuel can affect the environment because which can cause global warming. Unlike using renewable energy. Renewable energy does not produce carbon dioxide and affect the environment. Okay, our objective, the aim of our research on wind produced in Putrajaya are to find ways to maximize wind usage in order to increase the electrical consumption. Second, to study the use of renewable energy wind as an alternative way. Third, to determine the wind power density of Putrajaya. Significance of our study. The study contribute the necessity of renewable energy. First, it would not run out because renewable energy is the energy obtained from the environment, which will continuously obtain. Unlike non-renewable energy, which can finish anytime. It is not a forever source to obtain for electrical consumption. Second, cause less effect on the environment than many other energy sources because it does not produce carbon dioxide like in non-renewable resource. Third, cost effective because it is one of the lowest price renewable energy technologies available today. So you know that renewable energy costs very less compared to non-renewable energy. Fourth one is to understand the importance to study the wind speed in Putrajaya. In order to know the turbine's function, we have the major factor is wind speed. So it is necessary to know the wind range, the important wind speed to run the turbine. Is there anything else? Okay, that's all from me. I'll pass it to my friend Samuel.
Okay. Good morning to Dr. Zaina and my fellow classmates. Today, we're going to present the part in charge, which is literary review. Okay, in this chapter, I will explain the literature study that is related to wind energy in Malaysia, profile of the wind, and also the process of harvesting electricity from wind energy by different turbines with different location. Okay. First is wind energy in Malaysia. Wind power is a type of renewable energy potential in Malaysia. But Malaysia is a country with a low speed area compared with to other countries like China and United Kingdom. Okay. In Malaysia, majority of existing wind data will not for wind energy exploitation purpose, but it purpose for weather forecasting and airport use, and mostly provided by Malaysia Meteorology Department (MMD). So currently, wind energy in Malaysia is not meant renewable energy harvested in Malaysia. So we can say that Malaysia is still on the road to study the potential of the wind around the country. And as now, currently, we know that the area which identified as tight wind areas around Malaysia is in Peninsular Malaysia, Johor, Musing, and Kuala Terengganu. And then from East Malaysia, Kudat, and Sabah. Okay. Our average wind speed can reach around 3 meters per second at the height 60 meter height. Based on the resources, MR in 2006 until 2008 here at Mersing, Melaka, and Kuantan. So we can conclude that Malaysia is confronted with the issue of low wind because the speed of the wind still cannot reach the minimum requirement for the wind turbine to harvesting the electricity. So next, the wind study project in Malaysia. Okay, Malaysia have been installing some wind turbine for educational research since our wind or speed cannot reach the minimum requirement for the wind turbine harvesting the electricity. But we have some wind turbine also for our educational. So the first is the at Pulau Terumbu, Layang-Layang, which is located at Sabah by Tenaga Nasional Berhad (TNB) in 1995. And then the second at Terengganu, Pontianak, Iceland. Third, Kudat, Kuching, Kolopolis, and Terengganu. And then the fourth is Setiu, Terengganu, conducted by University Malaysia Terengganu. Okay, next. Okay, talk about the wind speed. As we know, the speed is the distance we can travel in a certain distance. Okay, and the wind speed is the pressure gradient that provide the impetus for the movement of the air. So, as from the research, we can know that our wind is blown from the Indian Ocean and the South China Sea. And the monthly mean wind speed is between 1.5 and 4.5 meter per second. So the high altitude areas can harness between 9 to 11 meter per second of the wind power. Then the wind energy is hardly harvested since most of the wind turbine need minimum speed of 4 meter per second for electricity generation. That's what I said. Our mean speed is still lower, so it's hard to harvest the electricity. So as a result, the analysis revealed that Kuala Terengganu and Mersing exhibited the best wind energy potential compared to other area with wind power densities WPD per year of 32.50 and 85.61 watt per meter area, respectively. Sofian at 1995. Okay, then next slide. Okay. Furthermore, Malaysia has two different main season weather, which southwest monsoon at May to June and northwest monsoon from November to March. During the southwest monsoon are often below 7 meter per second, but during the north monsoon, wind speed could reach up to 15 meter per second, particularly in the east coast of peninsular Malaysia. Moreover, during April to September, the effect from typhoon striking neighboring countries such as Philippines may cause strong wind even exceed to 10 meter per second to Sabah and Sarawak. Okay. This is a picture that shows the wind speed at 18 meteorological session in Peninsular Malaysia. Okay, next. And then wind direction. Okay, wind direction is a study about the direction from which the wind blows. So wind direction change are including the frequent meandering of the wind direction, Christensen and HANA and LT for common southern wind direction shift and more. Influenced by Stefaning gravity wave, density current, cause and drainage flow, and numerous other more complex signature. Okay. Next. Let's talk about the process generating electricity from the wind turbine. We have two processes that we can generate electricity from the wind turbine. So the first process is convert the kinetic energy from the wind to the mechanical energy using wind turbine. And then the second process is convert the mechanical energy from the first process, which is kinetic to mechanical, into electricity via the generator. Okay, next. Okay, the location of the wind turbine. So mainly we have two types of different location we can locate the wind turbine to harvest the electricity. The first is onshore wind, which are large installation with wind turbine located on land, and then the other location is on the water. You can see this is from Pulau Perhentian, which is located onshore, and then the second picture is from United Kingdom. This is offshore wind turbine. Next. Okay, we can see that this is a comparison between the onshore and the offshore of the wind turbine. So onshore is moderate speed wind turbine compared to the high offshore. Offshore had a high speed wind turbine. This is because offshore there is no building or trees or mountain that we block the wind, so that the wind can directly blow to the wind turbine. So the wind turbine can spin fast compared to the onshore. So the onshore wind turbine can damage to human life, and then the offshore will not damage to human life. And then the bad visual impact, if one of too many the turbine is built at the land, more than time, then that the human will feel that there is how to say very bad visual impact lah. And then the offshore is far away from the land, so the people will not see the wind turbine thing. So then the low erosion, and offshore is high erosion. Then the onshore, the wind turbine is low capital cost compared to the offshore wind turbine, and also the low maintenance cost for the onshore. I think if the onshore we easily to reach at the location, if we need to repair it or another. So for the offshore, we still have to travel to that certain location. It's far from the land, so that will cost our high maintenance cost. So the last is convenient accessibility and inconvenient accessibility. So my part is end from here. I will pass the next slide to my group mate, which is Tom. Okay, I stop presenting.
Okay, so this, am I share the slide right now?
Yes, just present.
Okay, so I'm Dong Jingyi, and good morning to my fellow friends and Dr. Zaina. I will discuss about the methodology, and in this section, divided to three. First was the materials, instrument, and then the calculation. So the main materials of wind turbine is steels and composites. Steel normally used for tower, mainframe, shaft, and gills, and the composite used for blades, nacelle, cover, covers and spanner. So what is the composite? Composites are the combination of two or more materials which different in physical and chemical properties. For example, was the glass fiber reinforced polyester. So can you see this picture? First was the fiber, which can be glass of carbon and combined with the matrix like polyester, epoxy, and last it will become the fiber composite matrix like glass fiber reinforced polyester. So why we choose composite as the material? Here are the reasons. Composite is stronger, more durable, low cost, lightweighted, and also corrosion resistant. Next was the instruments of the wind turbine. This is the component of wind turbine. First, I would like to explain about the anemometer. It used to measure the wind speed, wind pressure, and transmit wind speed data to the controller. And then was the blades. Normally, we use 2 to 3 blades in turbines, and wind flow over cause blades to lift and rotate. And then the rotor, this is the rotor which combined with the heart, and then the generator. And this is the yaw drive. Yaw drive is used to keep the rotor facing into the wind as the wind direction changes, while for the whirlwind, it measures wind direction and it works with the yaw drive to orient the turbine properly with respect to the wind direction. So next will be the considerations of wind turbine design. First was the turbine strength. The wind turbine should withstand extreme winds and high-speed winds, and the turbine blades we normally choose narrow and long for these modern ages because it's subject to less forces, and then the shape, weight, and materials used of the blade is also considered, and the number of blades normally 2 to 3. 2 blade horizontal axis wind turbine is lower initial than the 2 blade vertical axis wind turbine, and for the 3 blade, the initial is constant with yawing, but it will be higher cost. Okay, next was the rotor axis orientation. As I mentioned before, what is VAWT and HAWT? VAWT, the advantages of VAWT is that no yaw system required. It means rotor accept wind from any direction, and due to its simple design, the cost is lower. While for the HAWT, rotor solidity is lower. Average height of the rotor swept area is higher above the graph, and it tends to increase productivity of the wind energy. So this is the diagram. This is HAWT and this is VAWT, which can accept the wind from any direction. Okay, next was the climate factors, and for hot climate, extra cooling is needed for wind turbine, and for cold climates, keister and spatial lubricant is needed to protect them. Next will be the environmental factors. For environmental factors, we have to consider about the environmental impacts such as noise, visual appearance, effects of birds, and electromagnetic interference. To consider those impacts, a careful design is required. For example, upwind machine is more quiet than the downwind machines, and also turbines with lower tips and tower with perching can reduce the effect on birds. Okay, this is the last consideration for wind turbine design, which is roughness and wind shear. Wind hardly influenced by surface earth at 1,000 meters above ground level, but will affected by the friction against the surface of earth in lower levels of the atmosphere. So roughness of terrain, impact of terrain is referred as orography of region. The more pronounced the roughness of the earth surface, the more wind will be slowed down. So for example, for you know clearly and simply, like when we are when in the forest of large city with buildings, the wind obviously will slow down. Okay, next part is the calculation. Our data obtained from Meteor Blue, and we collect the yearly data by analyzing the data from the graph. And the raw data that provided from the Meteor Blue is temperature, relative humidity, precipitation, wind speed, and also the direction. And we take the year 2020 of Putrajaya, Malaysia, and the unit measurement for the wind speed is kilometer per hour, while for wind direction is degree. So this is the probability distribution functions that we use for wind speed analysis, but I will not go too details for the others, but for the value, our group is more emphasized to this two parameters value distribution because this is more widely used and more simple compared to the others. And next will be the wind direction finite mixture wand methods FMVM. The importance of the wind direction analysis is to identify the dominant direction of wind in order to maximize the capture of wind and hence increase the wind power. So this is the equations. And next will be the wind power analysis. The wind power analysis is wind power density, which means the number of watts of electrical energy produced per square meter of airspace. So this is the equation, and from the equation you can see this is FV bracket V is this is derived from the value distribution. So this is my part, and next I will pass to my friends Ku Jae Sing for the result and discussion. Bye.
Okay, good afternoon. I think you guys can read my presentation. Right. Can I have some response? Good morning. Hey, still no one responding to. Okay, then I start my presentation. Okay, click here to return the server. So this one as just now we thought. Why is still coming up this stuff of thing? Why? I think you guys can read the presentations, right? Or else cannot. Can I? Okay. Then nice. Okay. As just now in the methodology, Jingy talk about the data that we collect is from the methodology, Meteor Blue data. So over here you can see the wind speed, precipitation, maximum and minimum temperature data. It's collect for the Putrajaya in 2020. So I will proceed to the next slide. This one is the wind rows that the Putrajaya facing the direction of wind that experienced by the Putrajaya. So over here the wind speed more than 1 kilometer per hour is 699 hours per year for the south degree. You can see from the wind graph, and 5 kilometer per hour is 34 hours per year. This one is the the data from MetaBrew. So I will proceed for the next one. This one is for
this one we can talk about this for the wind direction. So you can see the wind direction is more to south. As this one is because of the monsoon reduced. Yes, now Malaysia got two monsoon reduced, which is southwest monsoon and northeast monsoon. It the duration for the southwest monsoon is May to September, and the northeast monsoon is November to March. So you can see from the graph the the highest speed that collected experience for the Putrajaya is in the February. This is caused by the northeast monsoon. As just now in Samuel's slide got stated that the northeast monsoons have the highest wind speed, but due to Putrajaya is covered by uh, that one. That Tiki Wangsa. So it showed that the southwest the southwest is the highest and the northeast is the lowest wind speed, but it's covered by Tiki Wangsa. So the most affect wind speed for the Putrajaya is the northeast monsoon. The average wind speed of Putrajaya in 2020 is 1.231 meters per second. As you see that over here, the wind speed is quite low. As even in February, the highest wind speed for the month is 2 point something. So the standard deviation for the wind speed for a year is 0.425 meter per second. So I go to next slide. The wind speed variation we had. So as we know, the higher the evolution, the wind speed will become higher. So as the location that we chose is Putrajaya, the ground surface roundness coefficient will affect the wind the height. I mean by the equation v equals to that velocity, initial velocity, bracket z z location over z0, the initial zero, and bracket to the power alpha, which the alpha is the ground surface roughness coefficient. So over here we can get because the ground surface roughness coefficient is affected by the terrain of Putrajaya. The terrain of Putrajaya is sub-run. So over here we can get the surface roughness coefficient is 0.257. So from the first data we get is for 10 meter high, as the wind normally setting on 10 meter high. I go through some research, but I cannot get the exact wind evaluation for the for the Putrajaya one. So I just I take it as not usual like average height of wind vane, which is 10 meter. So I will the initial elevation is 10 meter, and based on that I will add on 10 meter to get until 100 meter, which can see from the graph the graph will increase and increase so until the 100 meter. Or beside here you got the colors and else that it shows there. So at 100 meter, the maximum average wind speed is on February. As just now stated, the highest is in February. The wind speed is 4.16 meter per second. So I will only state the three height for the further analysis because from the statistic they found by wind now the highest percentage that the Europe wind turbine is around 3 meter per second. So this one is a available distribution that like just now Ingi got say about we focus on the available distribution because this one is most widely used in the wind turbine design. So as the data we take is from the say is 10 meter, so the graph shape will be the same as even though the height is different. So the graph shape is equal to 3.18 as you can see the graph shape is same, but the scalar wind speed for each height is different because of the speed the wind speed is different. So for 80 meter height, the scalar wind speed is 2.35 meter per second. 90 meter height, the scalar wind speed is 2.42 meter per second. And for 100 height, the scalar wind speed is 2.49. I can see over here that even though the highest frequency is 80 meter, but it doesn't can talk about it still have the highest wind speed density. So I will go to the next slide. We'll talk about the wind speed density. Okay, over here. The wind speed density on 80 meter height.
Can we go fast? You are
okay.
discussing your presentation slide. We're not discussing your presentation slide. Just go fast. Okay?
Okay. Then I go fast. The total hours for the 80 meter height. The total hours for the wind power density is 31.08 watt per meter square. While for 90 meter height, the total hours is 33.94 watt per meter square, and the 100 is for 36.97 watt per meter height, which the highest is 100 meter height. Means the wind power density, if you really want to install over there, is have to choose above 100 meter height. So for the conclusion, due to the data for the case study is just only 1 year data, it's not enough for us to really design, but it only can detect to know that indeed the location has the potential to build the wind turbine. So next, the main wind speed at Putrajaya in 2020, as I stated before, is 1.231, and the maximum wind speed that experienced by Putrajaya is 20 km per hour. Type of wind turbine is really want to choose because due to the direction of the wind is from different directions, so I chose the vertical one, vertical wind turbine, and of course it will be of onshore because in Putrajaya they even though they are river, but it's not suitable for us to put the wind turbine. The maximum wind, as just now got talk about the wind speed density right now, and I I will pass through it. So due to the location is not suitable for us to build a wind turbine because the electricity that used in Putrajaya is quite high because there are many building like government building over there. Plus the wind turbine is have the one of the limitation which is it will be noisy methodology, and as just now Samuel got say about that is the wind turbine will affect the human lo- human life. Just now it has said about that human life, and uh the transportation and installation is quite, because it has to build up to 100 meter, is quite difficult, as you will have to transport the things, the items, the components to the site. And if you really want to choose another regeneration energy power for Putrajaya, maybe solar energy can be considered compared to wind turbine. That's all from me. Thank you.
Group number 5, there's a lengthy presentation. I only give you 15 minutes. There's a lot of minutes you're taken. However, there's a lot not bad presentation. I think for the last one, Ko-Jisin, make sure you, if you presenting, you don't discuss your slide. Okay, next time if you have a time or you have an opportunity to present your slide, don't discuss your slide, present your slide. Okay, number one question for you, all of you. Number one question: can we artificially increase the wind speed in order to install wind turbine in Putrajaya? Can we artificially increase the wind speed in Putrajaya in order to install wind turbine? That's the first question. Any one of you, please answer that.
From my opinion, I don't think so. The wind can be artificially increased because the wind is unpredictable because it's natural. That's my opinion. I think.
What is the base of your opinion?
Huh?
What is the base of your opinion?
I think the wind only can come from the natural.
There's the wrong answer, because you already learn fluid mechanics. You can increase fluid power, right?
Yes.
From not from Bernoulli, from continuity equation, you can increase power of fluid, any fluid to including air lah. If you want to increase the velocity of air, you can use continuity equation, but you have to build a building that focus on your wind direction, so you can increase the speed of velocity of the wind. Okay. The question number two. Do you need to install wind turbine at the high position? Why? Other person.
Other person. You don't want, okay.
I don't want Samuel anymore. Other person.
Oh, you don't want Samuel. So sorry, can repeat the question.
Why do you want to install 100-meter height?
Because as just now we got say that the higher the height elevation, the wind speed can be captured is higher. So as the height increase, the velocity increase, this will it will recovers more wind speed, as you know that the wind turbine is by kinetic
So why don't
energy
you
from
install 1 kilometer height?
1 kilometer height is because the wind speed is too low for 1 kilometer height elevation.
How
If
do you
you
know?
want to
1 kilometer height, it is very high. 100 meter compared to 1 kilometer height.
as just now already talked about it, we use the equation of velocity equal to initial velocity bracket that
Kojisin, my
over
question is,
the
if you have a wind speed at elevation altitude around 1.231 meter per second, so you increase the height of your wind turbine. So my question is, what if you increase more than 100 meter? Why don't you put 1 kilometer high?
Hi, sir. Can I answer this question?
No, Samuel. No, Samuel.
Samuel.
Kojisin.
It's Jingyi. It's Jingyi.
Just now I already answered.
So your opinion or your calculation is, if you install further height, the wind will be low. Is that right to you?
The wind will be higher. The wind speed will be higher.
So
will be faster.
Okay, then why only 100 meter? Why not 1 kilometer or 2 kilometer or 10 kilometer high?
For that one will need for further study, but then it's quite difficult to build for 1 kilometer high.
It's quite difficult
The
to build.
installation method, because the things that the component that have to transport to there still it have the transport method.
Just build there. Build in Putrajaya. Don't transport anywhere. Just build in Putrajaya and build it, install it, and to 1 kilometer height. Can we do that? Kojisin.
We can do that for 1 kilometer height, but still need to do for the modeling things.
Yeah.
Like
what is your? I can hear you. What modeling? What?
Like some model to do some experiments first with the model. Then to get at least the ratio, to get the data. Or maybe Jingyi got better answer.
Kojisin, don't just say something that you don't know. As you said, I don't think we can build the tallest one. 1 kilometer is the tallest one.
Yeah.
Okay. Because the building is only not even 200 meter high. Okay. 1 kilometer is very, very far. It's almost impossible to build that high. Okay. Okay. Thank you, group number 5. Thank you, Sri, Samuel, Tong, and Ku. That's your question, and very good presentation. But your slide is very sad. I almost sleep. Okay. Thank you again, group number 5. Don't forget to upload all your PowerPoint to the Google Classroom. I will give a mark from that and also from this presentation. Thank you again. Thank you for your time. Hope that you have a very good PKP day in your wherever you are. Okay. Thank you. Goodbye, everyone.